All right, today we're looking at characteristics of linear functions. First, I'm going to go over some vocabulary. The first thing we're going to go over is interval notation, and this is how we're going to express our domain and our range. And interval notation is just a way to express the domain and range. Interval notation, and you have this on the sheet you received in class. If you did not pick one up, you don't have to, but you're welcome to use this to take your notes on. It is available for download on my website if you did not get one in class. So the interval notation is a notation representing an interval as a pair of numbers. The numbers are the endpoints of the interval. Parentheses and or brackets are used to show whether endpoints are included or excluded or included. So if your endpoints are excluded, we'll use parentheses. If they're included, we'll use brackets. Now, one thing with positive infinity and negative infinity, those are always in parentheses. A negative infinity will always have a parenthesis to the left. Positive infinity will always have a parenthesis to the right because there's no number higher or lower than those two. Also, we're going to be taking a look at the interval of increase, and that is the y value increases as the x value increases. So we'll be taking a look at that. Also, interval of decrease, and that's when your y value decreases as the x value increases. So that will be a decrease. And end behavior, and that's the appearance of a graph as it is followed farther and farther in either direction. So we'll be taking a look at that notation as well. And we've taken a look at end behavior before in Unit 1, so that will be a slight review. And also, depending on what you did in 8th grade, interval notation may also be a review. And we looked over that a little bit in Unit 1 as well. All right, our first problem. All right, the first problem we're going to take a look at is problem 1, and we're given the interval, or we're given the equation 4x minus 8y equals 16. Now, first thing we're going to take a look at linear, and we're going to do everything linear today. I'm going to recommend putting it in slope-intercept form, and that's just going to help us in a few ways. So first, I'll subtract 4x from both sides. Let me just rewrite that up here. So subtract 4x from both sides. So that gives me negative 8y equals negative 4x plus 16. And I'll divide both sides by negative 8. So that function is y equals positive 1/2 x minus 2. All right, so when we graph this, we have a y-intercept at negative 2 and a slope of positive 1 over 2. So there is our line. Now, when you're describing characteristics of linear functions, you don't have to graph it, but I'm just going to show the visual of graphing it as we describe these. So it is an option, though. All right, for domain and range. Domain, just as a review, that's all our inputs. It's all the possible x values of that particular function. For linear functions, your domain is always negative infinity to positive infinity. So we can have any x value on the x-axis and substitute it into the equation and get a y value. Any x value ever. From negative infinity all the way to positive infinity. It doesn't matter. Now, your range for a linear function is also the same. It's eventually going to cover all the different y values, from negative infinity up to positive infinity on your y values. So for domain and range for linear functions, always negative infinity to infinity, negative infinity to infinity. Now, we also can express that as all real numbers. So another way is all real numbers. And we can use that notation. You draw two parallel lines and then an R through it. And that also represents all real numbers. So the range, once again, we can say all real numbers, because any real number is going to eventually, because of those arrows, be covered. So we have that one. All right, but this will work for those linear lines. Now, there is some exceptions. If you have a linear line, for examples like x equals a number and y equals a number, those are slightly different, and we'll be taking a look at those as well. All right, x-intercepts and y-intercept. X-intercept is where we cross the x-axis, so we cross the x-axis at 4, 0. Our y-intercept is where we cross the y-axis, so that's 0, negative 2. Now, one advantage of putting your equation in slope-intercept form, it's our slope, and our y-intercept. So we know our y-intercept was -2 from that equation. Now, if you choose not to graph and you need to find the x-intercept, you would find that algebraically, and we've taken a look at this before. You could also find it algebraically by substituting 0 in for y and then solving for x. So that's another way as well. So you get to choose on which way you'd like to find those. All right, intervals of increase and decrease. Now, when we're looking for intervals of increase and decrease, for a linear function, it's going to be the same. So you're only going to have either an interval of increase or an interval of decrease. Now, when we take a look at increase and decrease, we always take a look as x is growing. So x is moving to the right. What are happening to our y values? We have an interval of increase if our y values are increasing as x increases. We have a decrease if our y values decrease as x increases. So this one we have increase, because as x values increase, our y values increase as well. So we don't have an interval of decrease. So we don't have to do the interval of decrease for this one. But sometimes it may be interval of decrease. Our interval of increase, and we're going to express it in interval notation, is going to be -infinity to infinity. It's all of those points. And once again, positive or negative slope. This one is a positive slope. We could tell a few ways. First, based off the equation, right, in the slope-intercept form, we have a slope of +1/2. And then you can also take a look at your line and notice that it's increasing. It's rising in the first quadrant. So either way works. Now, the second part of number 1 is the end behavior. Now, the end behavior is going to be the directions that x and y take. Now, for this linear line, our end behavior is always going to be either one's always going to be positive infinity and one's always going to be negative infinity. So for these linear lines with x and y, it's going to be one or the other. So our end behavior, as x approaches negative infinity, so as x is going to the left, we want to know what y is doing. And if we notice, as x is moving to the left, as we're decreasing our x values, our y values are also decreasing. So y is approaching negative infinity as well. As x approaches positive infinity, as our x values are moving to the right, what are our y values doing? Our y values are increasing. So you can sort of draw a triangle there. So they're increasing to positive infinity. All right, max and minimum value on the interval. Now, max and minimum value, you're going to do some algebra here. When you're asked to find the max and minimum value of a linear function, x and y, you're going to be given an interval. And the interval is going to be included with brackets, so they're going to include. So on this one, we're going to do the interval. So this is something you're going to write in on your notes. Or actually, it's there for you. So we're going to do the interval -1 to 1. Now, there are a few different ways you can take a look at this. On this interval, we're looking at our x values. So we're looking at the x value -1 and the x value +1. We want to find what the y values are. So when x is -1, you can either find that algebraically by substituting -1 in for x, and it may be helpful to look at that in the slope-intercept form because it's already solved for y. So when x is -1, we want to know what y is, and then we want to know when x is 1, what y is as well. Now, once again, you can always solve it algebraically by substituting the value in for x, solving, and that's your y value. We also can look at it graphically. So when x is -1, we want to know what the y value is. When x is 1, we want to know what the y value is. So you can look at it graphically as well. So you could sort of choose. I'm just going to look at it algebraically to get some practice there. So we have y equals 1/2 times -1 minus 2. So this equals -1/2 minus 2, which will equal -2.5. And I'm fine however you want to express it. I'm just going to express it as a decimal. So when x is -1, y is -2.5. And we can see that on our graph as well. So that's the ordered pair as well. All right, when x is 1, we get y equals 1/2 times 1 minus 2, which equals 1/2 minus 2, which equals -1.5 or -1.5. And we can also take a look at -1 and -1.5. So once again, you can find it graphically or algebraically, and that's up to you. Now for our max and min values, you'll always be, for linear functions, you're always going to have to given that interval. Our max value is going to be the largest value. So our max value on this interval is negative 1.5. Our minimum value is the smaller value. So our minimum value in the interval is negative 2.5. And one nice thing with linear functions, your endpoints, that interval that you're given, the y value of one of those is always going to be the max, the y value of the other one is always going to be the min. That's the nice thing about it. All right, the second problem, we have 2x plus 6y equals 18. Once again, let's write it in slope-intercept form. So subtract 2x from both sides. So we'll get 6y equals negative 2x plus 18. Divide both sides by 6. So we get y equals negative 1/3 x plus 3. We have a y-intercept at 3. Slope it down 1 over 3. So automatically you should be thinking, I have a negative slope here. So we can go ahead and circle that bottom one. Negative, bam. X-intercepts and y-intercepts we can also take a look at. Now my y-intercept is 3, so it goes 0, 3. And my x-intercept, once again you can find it algebraically or graphically, is going to be, I'm going to call it algebraically because that seems a little off to me. All right, so I'm going to know what our y value is when x is 0. Now I think it's easier to plug it into the given formula in that standard form. So we have 2x plus 6 times 0 equals 18. Nice thing about 6 times 0, it's 0. So we get 2x equals 18, so x equals 9. So our x-intercept is 9, 0. And I didn't do a very good job drawing that line on my program. All right, once again for linear functions, our domain is always negative infinity to infinity, and our range is always negative infinity to infinity. It's going to eventually cover all the x values with the arrows and all the y values. We can also represent that as all real numbers. All right, now intervals of increase and decrease. Keep in mind if you have an x and a y, you're going to have one or the other. Now as x increases, my y value are decreasing. So since my y values are decreasing, I have an interval of decrease here. And that's all my values, so negative infinity to infinity. So you're going to have one or the other. All right, the next part, we have the end behavior. So as x approaches negative infinity, I want to know what y is doing. And if I can sort of draw that triangle, my y values are increasing. Here's my x, here's my y. So my y values are approaching positive infinity for this one. As x approaches positive infinity, my y values are decreasing. So they're decreasing to negative infinity. And max and min on the interval, y'all are given the interval negative 10, negative 3. So when x is negative 10, and this one is going to be helpful to think of it as y equals negative 1/3 x plus 3. Substitute negative 10 in for x, so that will be y equals negative 1/3 times negative 10 plus 3, which is going to equal positive 10/3 plus 3. Think of that as a mixed number, so that will be 3 1/3 plus 3, so that equals 6 1/3. And when x is positive, negative 3, we get y equals negative 1/3 times negative 3 plus 3, which will equal negative 1/3 times negative 3. Think of that as over 1. That is going to be positive 3 over 3 plus 3, which equals 1 plus 3, which equals 4. So keep in mind our smaller value is going to be our minimum value, so that will be 4, and our larger value will be our maximum value. Now we can also take a look at that graphically as well, because when x is negative 10, that y value is going to be greater than when x is negative 3. That y value is greater, so that's our max value. All right, I will see you tomorrow. Hope you have a great evening.